Earth spins at 1,000 miles per hour at the equator, creating the cycles of day and night, shaping the planet we call home. But what if it all stopped? What if the Earth, spinning for billions of years, was suddenly motionless? Would life survive? What would change? And how would this reshape everything we know about the planet? Let's explore the scientific truth and unravel this fascinating scenario. Before we dive in, make sure to subscribe so you never miss an opportunity to explore what could be. Earth's rotation is a legacy of its birth. During the formation of the solar system, around 4.5 billion years ago, gas and dust collapsed under gravity and began to spin, a process known as conservation of angular momentum. Think of spinning a fidget spinner. When you let go, it keeps spinning until something slows it down. Earth has been spinning ever since, with only minor changes caused by gravitational forces from the moon and sun. Now, let's push science to the limit. What if Earth's spinning stopped completely? The outcomes are as fascinating as they are terrifying. Stopping Earth would also stop the ground beneath your feet, but the atmosphere wouldn't get the message. Winds would continue moving at the planet's former rotational speed, over 1,000 miles per hour, especially near the equator. These winds would be catastrophic, flattening cities, forests, and anything in their path. The kinetic energy from the atmosphere's motion would produce winds faster than the strongest hurricanes ever recorded. For context, Category 5 hurricanes, the most destructive, only reach around 200 miles per hour. The oceans would also maintain their momentum. Water would surge violently in massive tsunamis, spreading toward the land with unimaginable force. Coastal regions like New York, Tokyo, and Sydney would be submerged almost instantly. Without rotation, half of the planet would become trapped in eternal daylight, exposed to the sun's unrelenting heat. Temperatures would soar to over 200 degrees Fahrenheit, 93 degrees Celsius, evaporating water and turning land into deserts. Meanwhile, the dark side would plunge into extreme cold of negative 200 degrees Fahrenheit, negative 129 degrees Celsius, creating a frozen wasteland. Models studying tidally locked exoplanets, planets that don't rotate, support this prediction. The intense temperature gradient would make most of Earth unfit for life as we know it, except for a narrow band of twilight between the hot and cold regions. It's like cooking one side of a pancake on high heat while leaving the other side raw in the freezer. Earth's rotation creates a bulge at the equator, caused by centrifugal force. If the planet stopped spinning, this bulge would disappear. Water would migrate toward the poles, submerging regions like Canada, Northern Europe, and Siberia underwater, while areas near the equator would dry out, exposing ocean floors. This redistribution of water would take thousands of years, but would drastically reshape the planet's geography. Earth's rotation contributes to its dynamo effect, which generates the magnetic field that protects us from deadly solar winds. Stopping Earth would disrupt this effect, eventually collapsing the magnetic field. Without a magnetic field, Earth's surface would be bombarded by harmful solar radiation, stripping away parts of the atmosphere, much like what happened to Mars billions of years ago. Over time, conditions would deteriorate to the point where the atmosphere could no longer sustain life. Survival would depend on humanity's ability to adapt. Perhaps life could exist in the narrow twilight zone between the scorching day and the freezing night. Underground bunkers might shield populations from extreme temperatures and radiation. Science fiction often explores similar ideas. In the movie Interstellar, humans flee a dying Earth to find new worlds. While such a scenario is far-fetched, these narratives push us to think about our resilience in extreme conditions. Thankfully, the Earth stopping suddenly is physically impossible without an unimaginable external force. However, this thought experiment highlights how delicate our planet's systems are. Even incremental changes to the climate or environmental systems can have far-reaching consequences. Earth's motion is fundamental to life as we know it. It's easy to take it for granted, but understanding these systems can help us appreciate this extraordinary planet we call home. If you found this journey through science fascinating, make sure to like, subscribe, and hit the notification bell. Share your thoughts. How would humanity survive in a motionless world? Stay curious, because everything begins with a simple question: what could be?